Ready?
Right now.
Okay. Hi guys. This is our unknown hormone project. We are the Hormone Hooligans. Our unknown number is 325, and in this we have Brooklyn Crank, which is me, Alexa, McKenna, and Brienne. Okay. Our data, there's a lot of differences in both of them. We wrote down what increased and what decreased. What increased was the tibia width, the plasma, the pituitary weight, the seminal vesicle weight, and then what decreased was the body weight, the thymus weight, the adrenal weight, and the thyroid CPM, which is the the output, and the ovaries and uterus weight.
So from just that data, without any tests, we eliminated quite a few. We knew that it couldn't be TSH because it usually results in the increase of the thyroid in weight and in size, rather than increasing the production of the thyroid hormone like we saw. And then we had somatostatin, I apologize. It inhibits certain hormones, including the growth hormone, which doesn't increase the tibia width. It would rather do the opposite. Then there was HCG. The tibia width increased, which does not align with the effects of HCG. It would increase the thymus and the adrenal weight. It would not do that. And then the glucocorticoid. A glucocorticoid would probably decrease the bone growth rather than increase it, like we saw in the tibia. We also knew it couldn't be these. It couldn't be ACTH, which would increase the adrenal rate. And our adrenal weight did increase, but we didn't think it was significant enough for it to be ACTH. And it would reduce the body weight and decrease the bone growth instead of increase the bone growth. And we did have a reduce in body weight, but we thought that due to other factors, it could be something else, not just ACTH. And then there's estradiol. It is not known to increase bone growth. Usually it leads to a decrease in the thymus growth, which does not align with our data. We thought it wasn't also epinephrine, which because it would not increase the organ growth like it did in so many. And the weight gain is not significant enough for it to be epinephrine. And then placebo, it can't be, because it's a placebo and our tibia width and all of our growth doesn't seem, it just can't come from nowhere.
So these are the hormones that we possibly thought that it could be. We possibly thought that it could be growth hormone because of the increased tibia bone with the growth of the hormone or of the thymus increase the weight of it, and then the increased weight in the seminal vesicle. We also thought it could be thyroxine because it would decrease TSH and in turn decrease TH. We also thought it could be testosterone because of the increased body weight and the increase in muscle mass, also the increase in seminal vesicle weight, and it also because it stimulates the male reproductive system.
So, considering the data between growth hormone, testosterone, and thyroxine, we decided to begin with testing thyroxine, as most of the results indicated this hormone had the least amount of discrepancies for a hyperproduction, therefore making it our most likely choice. There were questions that followed growth hormone about the weight loss of the subject, and questions also came about with testosterone around the lack of change in the prostate and testes, as well as the adjustment in the seminal vesicle not being very big. We felt that testosterone would be our least likely choice. So following our results, this led us to request a radioimmunoassay test for thyroxine. The results came back that the control data was significantly smaller than the actual experimental thyroxine. There was an increase in the thyroxine found in blood plasma for our subject, and this kind of confirmed for us that thyroxine was our missing hormone. So this kind of like left us where we didn't have to test anything else.
Okay, so the unknown hormone that we picked was thyroxine. The data we collected led us to determine that thyroxine was the best match for our unknown hormone. We saw increases in tibioid width, plasma pituitary weight, and seminal vesicle weight, along with decreases in body weight, thymus weight, adrenal weight, thyroid weight, and thyroid output, and then also ovaries and uterus weight. For example, TSH usually increases thyroid weight, and testosterone didn't explain the minimal changes in the prostate and testes. The immunoassay test confirmed our choice, showing much lower thyroxine levels in the experimental group compared to the control group. This showed that the thyroxine concentration in the subject was elevated, making it the most likely hormone with the fewest contradictions.